Good. Good start. Good start. Thank you. Thank you. Hello, everyone. Hope you're all settled in. Hope you all grabbed some lunch as well. We're going to be spending the next half hour-ish, probably 25 minutes, talking about how we at Fanduel has built out a extensible real-time data platform. And I'll talk about all three of those different things throughout the presentation here. But for those who aren't out from the US, you might be wondering what FanDuel actually is. So we are the US's #1 sportsbook. We have over 12 million plus registered users, and the users that use our platform engage generally in more sporting content. So they'll watch more games, they'll watch more live events because they're engaged in kind of our mobile betting platform. That's me. I'm a senior data engineering manager here at Fanduel, and I primarily focus on our real-time platform. Personally, I've worked in data for about 13-ish years. I started off my journey doing optimizations with stored procedures in SQL Server 2005. I hated it. I thought to myself, I'm not going to work in data. I'm not going to touch SQL. I'm not going to touch databases ever again. And kind of made a career out of it, which is strange. But I've also had the opportunity, throughout my career to build and work on 3 separate real-time event systems from companies ranging from startups to big tech to different levels of scale-up or different sizes of scale-ups. Quick run-through of agenda. We're going to talk a little bit about how we use real-time data at FanDuel, very briefly touching on that. High-level overview of the platform itself that we built out, how we achieved extensibility or modularization, challenges, learnings, and I don't know if there's time for Q&A at the end, but if there is, we'll give some time for that. This is not going to be a super technical talk. We're not going to dive too much into code. There's no live demo. We're going to be talking high-level architecture, challenges and learnings, and all that stuff. I'm also not a vendor, so there's no kind of other salesy kind of motivation here. I will be shouting out some folks from Tinybird at the end as well because they were gracious enough to kind of give me their speaking slot. So we'll start off first with probably the easiest is real-time. What does real-time mean at FanDuel? Again, I'm not going to spend too much time on this slide. We're in the fast data theater. We hopefully have an idea of what real-time is and the benefits of real-time understanding. But at FanDuel, we use real-time data for investigations. If something goes wrong, something happens, we can go in and analyze the data or investigate what's going on. We use it for real-time analysis. So if a big game is happening, we can understand the data coming through, and we can understand if there's any adjustments that we need to make on our actual product itself. We serve data APIs for real-time or fresh data through the help of Tinybird as well, so that we also interact back with our customers and our product engineering teams to be able to surface that real-time data back up. And then for real-time reporting or near real-time reporting, it gives us quicker turnarounds because we have fresher data. We're not waiting for batch loads that are 1 hour, 1 day stale. We have information kind of as it comes in. Okay, diving a little bit more into the meat of things, I guess, for lack of a better term, we'll talk a little bit about the data platform and the platform that we built out as well. But I kind of want to level set a little bit here. This is a very, very high level overview of our general org structure or general way of doing things. But you can see kind of the focus on here. There's a step here I don't want to fall, but there's a data platform kind of infrastructure or a data platform team underlying a lot of the different services that we have. And we provide sort of the underlying platform that data engineers, data analysts, data scientists, ML operations, that they use in order to serve the data that they need. One other component that's not part of this diagram or the part of the slide is we also serve software engineers and product engineering teams as well through APIs or through direct consumption. So we'll talk about the data platform and the data ops side, half of that, the data platform, and then another half of that specifically for the streaming data platform. So this is a 1,000-meter view, 2,200 feet, depending on where you are, of our overall architecture. There's a lot of stuff that happens under the scenes. There's a lot of stuff that goes on, behind the scenes. But if I had to distill this down into one picture, this is kind of it. We have a number of sources on the left, or data sources that could be coming in from AWS SNS topics. They could be coming in from other Kafka topics. They could be messages in a variety of formats. They could be JSON. They could be protobuf. We ingest a topic that is stringified XML for some reason, and we need to process that. All that data lands in a Confluent Kafka cluster. Kafka clusters are notoriously difficult to maintain, so we also kind of outsource some of that maintenance as well. But there's a lot of stuff going on in the peripheries. But it lands in a raw topic, where then it goes through a bunch of transformations or a series of transformations. Transformations are being done in Flink because we needed some of the capabilities of Flink in a Java library, effectively, or a Java API, to be able to do some really silly stuff like deserialize stringified XML that a SQL-based language can't be able to use. All of that lands in another topic, a refined topic, where it's connected to schema registry, and then we send it off to all of our different destinations: S3, Delta Lake, Databricks on Delta Lake, Tinybird, as well as for our end consumers to actually be able to consume. Like I said, a bunch of stuff happens behind the scenes, but this is very high level what happens. I'll shout out Tinybird as well. They're one of our consumers. And that platform actually enables us quite a bit to perform the real-time analysis and generate the real-time APIs that we have. I may say the word adrenaline quite a bit throughout this presentation out of pure habit. That is the internal name that we have for our data platform. So if I do say adrenaline, this is what I mean, high level. So from a platform design philosophy, we have got a couple of things that we try and keep in mind. First and foremost, all data platform at Fanduel, or all infrastructure at Fanduel, is self-service by design. This means that we try to abstract away, or we try to make the platform, or building on top of the platform, as easy as possible. The interactions and the user experience for our data engineers is done through configuration files. That means they don't actually need to go in and write Flink code to make transformations. We provide a capability for our data engineers to do so. They don't have to go in and manage and maintain all the different source connectors and sync connectors and topics and all the complexities of managing Kafka. We take that responsibility away. We take away that complexity. So self-service by design, we abstract away a lot of complexity, not just for our users, but we try to abstract away complexity within our code base as well. And I'll show an example later. And that gives us the ability to be technology agnostic. So if, for whatever reason in the future, we decide to move away from Flink as our transformation layer, it's going to be difficult, it's going to be tough, but it's possible, right? We're not designing ourselves into a hole where it's just absolutely impossible or virtually impossible to rip out the foundation. We have that logical distinction in our code bases as well. And then last point there, interacting through configurations. Cool. So that talks a little bit about the data platform side, and I'll be spending a little bit more time on the extensibility side. So how we made components or our components of our data platform more modular, more extensible, so that we as data platform engineers can build on top of it, and data engineers, data analysts, software engineers can also build on top of our platform as well. This is a very simple example of what the user experience, or what the user interface in air quotes here, looks like for our platform. Everything is done through configuration files, and similar to the Red Panda talk right before this, it's fairly simple to define what a topic is and define what a sync is. In order to define a topic, you have very basic things like a name, which team owns the topic, and does it handle PII data? Is it a raw topic? And some minor configurations there. There's a couple of things to kind of make note of. This handles PII flag, does a bunch of stuff under the hood. It changes permissions, or it It sends the data into different landing areas. It sends the data into different components or pieces of our infrastructure where only certain people or with access and permissions are able to access it. So there's a lot of stuff that happens under the hood just kind of with a simple flag that gets configured on the configuration file. The Israel, kind of similar things. There's lots of validations and checks the schema registry depending on whether or not that flag is set to true or false. And that kind of is an example of some of the abstractions that we try to take away so that our data engineers don't have to worry about, okay, which bucket do I need to archive this information into? How do I handle PII? How do I make sure that our data that's flowing through the platform is compliant? We build that into the platform itself. I'm not going to step down or anything, but I'll kind of point to the S3 sync. But the S3 sync is a very sort of similar story, right? You have some basic information, the name of the sync, the owners, does it handle PII data, which topic is it pulling from, and then in the particular example, it's an S3 sync, so you're specifying the buckets, the prefix, input format, output format, partition intervals, and all that stuff. And then the infrastructure under the hood is taking care of, okay, does this handle PII? I need to land it to a certain bucket. I will be spinning up the connectors that actually lands the data into S3. I will be able to handle scaling and the auto scaling that needs to happen under there as well. So modular definitions, and we try to maintain kind of a common way or a common approach for all of our different delivery definitions. That's not always the case, and I'll come back to that a little bit later. There could be some complexity just because some stuff can be complex, but high level, that's what we try to do. This also extends, or that extensibility or that modularity kind of concept also extends into how we build the code under the hood as well. So since all of our resources are kind of logically split, meaning that we only have sinks and sources and a bunch of transformations and a bunch of topics, we can actually split that up logically in the Arden code base so that it is modular and defined. I'll show an example of that. I don't know if you can see this in the back, so I'll kind of walk through this code snippet, but this is effectively, 50 lines or something of code where you can define a new sync connector. So at the very top, you have a bunch of configuration options, and you define the model. You have the topic name, the input format, output formats, and then you go into configuration option A, B, C, whatever you do. You can add validations to this model as well that all gets run and all gets picked up. So you can guarantee that things like topic names are properly formatted. And there's, if configuration option 1, configuration option 2 are mutually exclusive, you can add a validation to say both of these cannot be false or something like that. And then the schema just converts that model and dumps it into kind of a schema or configuration file that we deploy later. So there's lots of stuff that needs to be built around this, but this is kind of the core of what a data platform engineer needs to do in order to build out another sync or a new sync. So fairly modular, and all of the logic and all of the underlying information or requirements on networking and infrastructure setup are set up by kind of those base classes as well. Transitioning a little bit more into how we deploy things, but I'm not going to show you a build kite pipeline or code for build kite pipeline. That's a little too much. I'll just say this, and hopefully you all trust me, that our CI and our build pipeline is able to handle a lot of these new definitions. So whenever a data engineer, data analyst creates a new configuration file, it will automatically be picked up by our build pipeline. And whenever we make a new connector or a new class, that is also able to be picked up automatically by our build pipeline as well. And then our build is able to spin up the infrastructure, run all of our testing, and be able to essentially provision all the resources and deploy them in a reasonable fashion. And then the last point I want to make is that as a data platform, we had an early and often investment into testing. We have full end-to-end tests being run for all of the resources in a production-like environment. This means that for any connector, any topic, or any resource or any piece of infrastructure that's spun up, we have essentially in every single build kite pipeline or every single build, we will deploy that to a lower environment, a production-like environment, run a actual data through an actual piece of infrastructure or an actual resource that's deployed, and then check to see if the data arrives in its destination in appropriate time. There's a lot of upfront work to do that, but it gives us the confidence that whenever we make any sort of core changes, we're not drastically breaking things. Yes, sometimes things slip through the gaps, but it gives us a lot more confidence that if a build passes and all these tests run and all these tests pass, we can confidently push this to production. And that gives us the ability to have quick turnarounds for new feature updates, bug fixes, or whatever, where we can promote and deploy our infrastructure to production without worrying as much about it breaking any of our downstream consumers. I am okay for time. So I'll spend a little bit more time here on the challenges and some of the learnings that we had building out the platform itself. This requires a lot of upfront work. If you think about how Fanduel and how the actual ways of working that we have at Fanduel actually are structured, we need to serve a lot of different use cases and a lot of different types of pipelines. So, we can't possibly, as a data platform team, imagine all of the different business use cases that could come through the door today, let alone 6 months from now, a year from now, 3 years from now. So we need to be very strategic in how we build out some long-term capabilities while still being able to deliver short-term solutions. So we're constantly looking for opportunities when the business approaches us or data engineers approach us and say, can you build out this functionality? We want to approach it with how do we deliver a short-term business value while also being able to build out for the long term, build out a feature or a capability that is able to be used 3 years down the road. Some of our interfaces, those configuration files, can also get quite complex, for lack of a better term. I showed you some simple ones, and most of them are quite simple. But if you're, I'll use the example of deserializing XML. If you're deserializing XML, there's difficulties in making that very simple in a generic fashion. This means that you need to define interfaces through the configuration, you need to define schemas through the configuration file. You need to define what the source data actually looks like, what the destination actually looks like as well. So there's a little bit of complexity in some of our interfaces. We, as a data platform, need to have deliberate investment in support and knowledge transfer, something that we will continue to work on and are continuing to work on, but we are looking to offer kind of some knowledge training for our data engineers, our customers, to be able to use the platform as well. A very important one is, again, because we're building out a generic, or trying to build out a generic and self-service platform, what are the actual capabilities that we need to support? We can't support every single input format that ever exists. We also can't support, if someone sends us stringify protobuf, for example, we can't go and say okay, we'll build out a connector or build out a transformation that does that for you. So we need to, as a data platform team, deeply understand the business value and the business requirements of some of the new features that we need to build out. We actually need to go out and talk to our product owners and talk to our software engineering teams and product engineering teams to say, what will this be used for? How will this impact the product that we're building? How will this impact our customers? How will this impact revenue? And all these other kind of high-level metrics that we need to do, so that we understand what is the right pieces of, what are the right components that we need to build into the platform. There are only so many hours in a day. I only have so many number of people on my team. We can't do everything, so we really have to pick and choose. And it can't just be, the squeaky wheel gets the cheese. We need to go in and do our own investigations of what is valuable for us to build. So that's one side of the coin. On the other side of the coin, I know, there's a number of data engineers from Fanduel who say hey, we really actually need to use some of this functionality. Yes, it may not be as high priority in terms of business value side, or there might be other pressing things, and your team is swamped, but we really need to be able to introduce some of this functionality. So that's something that we're investigating right now, or investing in more right now, is how do we encompass or allow some more of the custom logic, some of the more custom feature sets, or some of the custom connectors, so that other data engineers and other engineers are able to contribute to the platform. But we also need to make sure that these guide rails and guardrails are in place. Because we're a sports betting or a sports gaming kind of company, the data that we have is fairly sensitive, or can be fairly sensitive, and there's lots of regulations and regulatory bodies that come through. So we need to have some of these guardrails in place, set in place by the platform and our infrastructure, before we can kind of open up the floodgates a little bit more. We're slowly opening things up, but this is something that we are deliberately, sometimes deliberately kind of closing off because of those regulation things, and we are opening up slowly more and more. Like I said before, I don't think this is too much of a mind-blowing or any sort of super insightful, or not insightful, but like super mind-blowing kind of talk. This is more about reinforcement about this is how we do things at Fanduel. Maybe you can take some learnings back to your companies or the people that you work with to say, we are able to do this at the scale that Fanduel operates. Maybe we can take some of these learnings back. I would also like to thank the folks at Tinybird for giving us this time slot. I'm sure they could have used this for other purposes as well. But our Tinybird friends, I think they're at booth 4749, just over yonder, so go give them a check out. We use Tinybird quite a bit for real-time analytics and real-time API usage. And while we do have a couple of minutes, I don't know if we can field questions or not, yay or nay. But more than happy to take a few questions if people are interested. No? All right. Thank you, everyone. Appreciate it.